Compound events are more than one event occurring.
Holy cow.
I know. For example, what is the probability of drawing a king or a heart?
Well, that's not part, that's H.
I want to talk about probability of getting a king or a heart in one draw, a single draw out of cards. How many cards are kings? 4 of them. 4 out of the 52. How many of those are hearts?
1.
Hearts. King or heart.
No, I thought you meant out of the kings.
Oh, I mean, or I'm talking about how many of them are
okay.
hearts.
Alright.
There's how many hearts in the deck?
13 before, well, one of them is.
And one of them, and one of them has been double counted, so we have to back one out, the king of hearts. What you're thinking about here is your basic, old-fashioned Venn diagram stuff. You have the kings. And then you have all the hearts.
Do I have a heart sticker?
I do.
Be in the shades. Yours was better.
I lost count. 8, 9, 10. So it's the intersection and union. Remember those?
No.
That's what these are. In this case here, we have to back out the king of hearts because it's already been counted here. That's what this looks like. So what's 4 plus 13 minus 1?
16.
Out of how many possible?
52.
There's probability. 16 out of 52.
4,
4 13ths. Very good.
I can imagine this.
That's a compound event. More than one event occurring. And it's different than saying what's the probability of the king of hearts? 1 out of 52. That is the one specific card you're looking for. Now let's try another one. What is the probability of picking a 6 or 7?
Is this one a drive?
I'm picking a card. Sorry, I'm still talking about cards here. Probability of getting 6 or a 7?
4 over 52 plus 4 equals 8.
Okay. What about this? The probability of a jack and a 3
in one draw.
in one draw.
Like, you pick one card, and it has to be a jack.
Right. It would be 0.
Wait, what? I'm saying
Hold on.
What's the
You got
probability
jack
in one
and
card I'm
one
going to pick a
card.
jack and a 3?
Well, if it's
Depends
magic.
on the deck you're
It
playing.
depends who picks it.
If it's been doctored.
Did you ever find your cards?
No.
I can bring.
So they stole my cards and PO'd about that, but
What's the probability?
Like a P.O. box.
what's that?
What's the probability you got stolen?
Closer to 1 than 0. Okay. Excuse me. When you go into the whole idea of the dice rolling again. If I go back to the dice rolling, I got this silly update driving me nuts. The idea of the probability of a sum of, we did this yesterday, 7 or a 9. Those are compound events. You did that yesterday. You just didn't realize you were doing compound events. You counted the number of those, you counted the other ones, you put it all together. And you had 10 out of 36. That's a compound event problem. Correct? So you've seen this. You just didn't realize you were doing this. Now, the book does go a little bit longer way of talking about what are called unions, intersections, and what are called mutually exclusive. The union is all the stuff together. The intersection is the overlap. And a mutually exclusive event is when they have absolutely nothing in common. And you'll see this as we get more into these dependent, independent stuff. You don't need to write all that out. I just wanted to just say that is that if they're mutually exclusive, there's some, it's your A or B, but there's just no overlap. That's the rolling, or picking a 6 or picking a 7. There's no overlap of a 6 of 7s. Does that make sense? That's all that is. We will do a little bit of this where you'll have the probability of A or B is going to be the probability of A plus the probability of B. Subtract out the probability of A and B. This is the long form, this is the long form of the probability of a king or hearts. That's the long form way of doing it. The probability of picking a king, 4 out of 52. The probability of picking hearts, 13 out of 52. What do they have in common? The king of hearts. That's where this intersection, the A and B, came into play, the king of hearts. Does that make sense why we wrote it that way?
Yes.
That's all it means.
Easy enough.
Then when I said the probability of getting a 6 or a 7, well, there's no overlap of a 6 or a 7. That's why it was just 4 out of 52 plus 4 out of 52. You didn't have to back anything out. Like I said, there is no 6 of 7s.
So,
6 of 7.
What's the 7 and 6?
only when there's an overlap.
You have to back something out. Yes, and you'll be able to figure that out real fast because it's that card problem. You're backing something else out. Okay. Shipke, did you have something? You okay?
Yeah.
Okay. A card is randomly selected from a standard deck of 52. Nothing up my sleeves. What is the probability it's an ace or a face card? Well, how many aces are there?
4.
How many face cards are there?
12.
What's 4 plus 12? Out of?
51.
Is there an overlap? There is no ace of face. There's ace of base, and if you saw the sign, you'd open up my eyes. Okay.
So sorry.
I'm drowning here. I'm trying to figure it out myself.
That was a joke.
A card is randomly selected from the standard deck. What is the probability the card is a heart or a face? Heart or a face? Well, how many hearts are in a deck of cards? 13 hearts out of the 52. How many face cards are there? 12 out of the 52. Is there an overlap between hearts and face cards? 3 hearts and face cards.
Yeah.
I'm trying not to say 3 hearts in the cards. You really have to focus on not saying that. So you back out 3 of them, which gives you an overall probability of 22 out of 11 out of 26. Okay. Yes, sir.
Is it okay if you answer the problems in percentages?
Yeah, that's fine. It's more often than not, people write, a lot of these probabilities just get written out as fractionals. Fractions, decimals, percents, either one of them is fine. Personally, I would do fractions or decimals because even when you do percents, you still got to move things around. It's just one extra step that you could accidentally screw up. That's all. But if you're comfortable with it, I have no problem with that at all. And don't let it be greater than 1.
So you don't have a greater than 100% chance to do anything.
I wasn't. I was just reminding him that probabilities are never greater than 1.
The funny thing is that when that statement is as funny as all the other kids. I think that was a roast.
I'm not like
No, I'm like, really?
Does that qualify as a roast?
Guys, come on.
Studying pop culture.
It's just tired. It's a Monday.
Down in the.
Compliments. They're not nice to give to people. They're also nice to use in math. That was supposed to be funny.
That was good. That was good.
It was not nice to do.
They're not just not nice to give.
Oh,
That was a good one.
So when we use what's called a compliment, I want you guys to think of it as using a compliment is a shortcut. But I'm going to show you how you can use it with something really, really easy. For example, what's the probability in a single die to roll a 3? 1 out of 6. We know that the probability of rolling that be 1 out of 6. What's the probability of not rolling a 3?
5 out of 6.
Now, given the fact that we're rolling a die, we're going to get some number, correct? So the probability of rolling the die is going to be equal to what? 1. So what happens here is that the probability of rolling a 3 is 1 minus the probability of not rolling a 3. The probability of not rolling a 3 is 1 minus the probability of rolling a 3. They're complements of one another. It's a really easy thing to use, especially with dice, when you have larger data sets to count off of. You guys saw counting 36 numbers. It's pretty quick to go through. Oh, it's 10 of them and whatnot. But if we go back and look at that double roll setup where I think it was the probability of, let's just say the probability of rolling greater than or equal to 4. I have to reset my computer because there's a PDF Adobe update, and I don't want to stop this. I will lose my 52,000 years, which means that none of my tab switchings work anymore. Finally. But if I go back to the PDF, it won't go because there's a
make it harder.
trust me.
you try to turn your computer off.
I'm gonna lose my 52,000 years of lottery.
Wait, 52,000, what's that actually?
I've been running. When did we start probability? Last week?
You haven't turned your computer on since that?
No.
Yeah, like last.
I closed the lid, but I don't
So
start
you've
it
been,
hard
you've been
now.
running it for a week?
2 weeks.
Terrible
Anyway, so the probability of rolling
You should just keep it on also.
greater than or equal to 4. So if I want to roll a sum that's going to be greater than or equal to 4, it would be the same as saying 1 minus the probability of rolling less than 4. Isn't that easier to count?
Well, like, I'm gonna say.
So less than 4 is how many of them? 3. Everything else is 4 or greater. So I would say 1 minus 3 out of 36 gives me what? 33 out of 36.
It is 11 out of 30. 11 out of 12. Right.
Using complements is just quicker sometimes. That's all. It's just quicker. It doesn't necessarily mean that you have to, but believe me, anytime you have a larger data set, doing the opposite, subtracting it from 1, it's just a faster method. That's all. It's just a lot faster method. What was the other one I have for this one? Probability. Question. The sum is not 8. The sum is not 8. So if I want to get the probability of the sum not equaling 8, wouldn't it be easier just to count the ones that equal 8?
Yep.
Brilliant! How many are there?
Hi.
5. So how many of them are not 8?
31.
There you go. No. And then we just did the greater than before, so. What's that? Like the table. Isn't this table here like okay for dice?
Can I have a pair of dice with my test now?
I don't know. I haven't decided. What were the problems? I switched it up and I forgot what numbers I wanted to do. So we're going to do this versus 2 days. We'll talk about the other equation versions of the probabilities and some of the table stuff tomorrow. Do these. The 7, 27, 29 through 40.
Thanks for cutting some of the problems out. Makes me very happy.
So let's see. It's 7, 27, 29 through 40.
9 or 29?
Why is that?
And then